Hello, good morning. I think we can start right now. I know that, the portal is a bit narrow and it will take time for people to come in. Really, it's our problem because it takes a lot of time to get so many people inside the gateway. But without much ado, since we have a lot of ground to cover in today's webinar, let me invite all of you. And let me jump straight into the topic. We as engineers are rather coy about discussing failures. But really, it is failures which teach us lessons, not successes, right? So we at SEFI have taken the plunge and we've decided to host a series on learning from failures. And it would be of interest for you to know that this is not unique. This kind of webinar that we are trying to begin the series of webinars that we are going to initiate today. This is also being done in a different way by ASCE, and I will share some details about it, on the SEFI discussion forum. And maybe, there are some opportunities to collaborate and learn from failures worldwide. And I will also take this opportunity to invite you as participants, to be part of the series. Do share your experiences of failures which you may have experienced or witnessed or observed. And we at SEFI will assure you complete confidence. We will redact. That means we will remove the names of all the consultants, contractors, clients, location, project name, and we will create a database just to pull out the lessons learned from that project. And we would perhaps be able to invite you to discuss this in a future series. So we will be creating a special section on that on the SEFI website. If any of you are not members of SEFI, I think our administrator, Mr. Sanjeev Kumar, will be giving you details at the end of this webinar about how you can become a member. And we will create this special section where you can anonymously also put in information, or you can also share your details. And it's only the only focus and objective of this is for others to learn from failures. Right? And also that way we will take away the stigma of failures and we could work together as a community to make a safer habitat, right? So the first in the series is the topic which we are going to talk about today. And really that is the point for where we start a project. That is the excavations and securing of the excavations. And I think all of us have at some point or the other heard from the community or even from the newspapers of a failure of a shore piling system or a collapse of, retained soil in on a hill slope. I think Mumbai has a very recent example of what happened on the Malabar Hill, and that main artery of Hughes Road was blocked for many, many months and caused, crores in terms of lost time because of the traffic buildup. So we today have a very eminent panel. I think the best we could have collected in India, and they are going to engage with us and they're going to share their observations and experiences of failures which they have observed or witnessed firsthand. And the panel will be introduced by Professor Shailesh Gandhi. I'm going to introduce Professor Shailesh Gandhi. Professor Shailesh Gandhi is erstwhile professor of geotechnical engineering in IIT Madras. He's also been the director of SVN IIT Surat. And presently, he is visiting professor at IIT Gandhinagar. Over to you, Professor Gandhi.
Yeah. So, am I audible?
Yes.
Okay. So a very good morning to all the participants, dear panelists, and the SEFI organization. I would first like to congratulate SEFI organization for choosing this particular topic, and also in general this series, which will help a long way to our geotechnical fraternity in furthering knowledge in different topics. And we have taken rightly a very important topic of shoring for deep excavations, which is a necessity in many of the infrastructure projects. We have with us four eminent panelists: Professor D.N. Singh, Senior Geotechnical Faculty at IIT Bombay. And then we have Dr. H.M. Raje from Raje Project Management Consultancy Company. We have Engineer Vaishampian from Subsurface Consultants, and Sri Jaideep Wag, who is from Geocon International. Now, I will be, as per the program, we have each panelist speaking for about 10 minutes. And as Dr. Alpa has already pointed out, let us try to avoid the names of the project or the, the builder, or so that there is nobody. Our aim is mainly to learn from the failure and how we can improve the situations. So we would be having the presentation in the order from left to right on this screen. That is starting with Dr. Sri Jaideep Wag, followed by Engineer Vaishampian, and then Dr. H.M. Raje, and Professor D.N. Singh. Now, I will just run through a few slides, raising some of the, I have flagged some of the issues which could be important for this group, and we will deliberate wherever you feel that this appeals you, that this needs further discussion. Now, we do have successful stories, and I am sure that the successful story of executing a deep excavation with soaring are more in number than the failures. But still, we should look into the failures and see that how we minimize them. What I would like to first bring out is that in the earlier days, people didn't have confidence that the soaring system itself can be a permanent element of the structure, particularly when it is diaphragm wall. So you have seat pipe or soldier pile or what Berlin wall, and then you construct a permanent wall inside after reaching the bottom. Is the soaring system proof checked? Like the corporation may say, you give me the proof checking of the building, but whether soaring system is also proof checked at various stages of execution. This is very important, and it should be insisted upon. Is due importance given to monitor various parameters using instrumentation? While this is happening in the metro projects and some of the government projects, I find that this is missing in many of the private construction, where there's not much budget given for instrumentation and monitoring, which will otherwise give some warning if there is any yield taking place. Is the external dewatering permitted? Many of the urban area in congested city where you have heritage structure around, the external dewatering is not permitted. And if it is so, I have two problems. The soaring system has to be designed for a full hydrostatic pressure acting on it. And second thing is, when we dewater inside to construct the base slab and the structures, you run the risk of piping failure at the bottom unless the soaring system is taken deep enough to
Professor Gandhi?
Yes, please.
Yeah, okay. We couldn't hear you for a minute. Yeah, go ahead.
Yeah, is adequate precondition assessment carried out for the neighboring structures? This is because many times we find that people try to exploit the situation. Though the building is cracked prior to the construction, they claim that the cracks appear due to the building, the basement excavation, and we should have a compensation for it. Okay. If the major issue is when you have so many struts in the soaring system, you find that working is so difficult and with a limited access to the bottom. So if we are looking for a strut-free excavation, one option is open excavation with side slopes. This will be preferred by the builder wherever it is feasible. Cantilevering shoring with lateral support like anchors so that the area is free. You may use the cantilevering shoring itself so that you don't need to put any anchor or strut. But beyond certain depth, it is difficult. Then we also have this top-down construction method to avoid soaring. And are there any other options? I just take briefly to some of these slides. This gives me this shows various issues which we may face. Watertight joints creating a problem of stability, subsidence due to escape of soil through the joints, corrosion of steel due to inadequate cover or faulty construction, extra consumption of concrete due to collapses during construction of the diaphragm wall, monolithic joints with basement slab at each of the basement, piping failures due to inadequate penetration of the shoring system below the excavation level, and can we install the shoring system up to the property line? Because some of the CREDI complain that corporation does not permit us to go up to property line and we have to leave certain distance, and that loses so much of parking space in the basements. The instrumentation can be in various form. I will skip the slides because we all are aware of various instrumentation. I was telling you the first choice is to go for open excavation. There are two problems. The volume of soil you excavated could be 100% extra if we include the volume in slope. Second thing is taking the soil out in urban area with a limited timings available for truck movement and again getting it back for backfilling. That can be a problem which can be resolved by shoring. If we have a shoring in form of a diaphragm wall, this particular has an anchor at the line of anchor at the top in the coping beam. You see that joint, though tried best to have a watertight joint, sometimes you have a leakage through the joint, and along with the water, sometimes the soil also comes out. So this leads to a subsidence of the area behind, leading to even collapse of the building along the perimeter if a lot of soil escapes through the joint in this system. Inadequate cover, reinforcement getting exposed. This is also commonly seen in various shoring system. Then you need to carefully identify such area, treat the rebar bar, and provide micro concrete or any other technique to see that corrosion does not progress further after the permanent work comes. Using RCC diaphragm wall as a sacrificial shoring system has also been used extensively, and we did not have enough confidence on use of the diaphragm wall as a permanent wall of the underground facility. This shows a wagon tippler, and you see RCC diaphragm. Are you able to see my cursor?
Yes.
You see the this permanent diaphragm wall built to make the excavation with strut, and then you have a permanent wall of the wagon tippler built within this excavated area, and you can see this is permanent RCC wall cast against formwork with required counterforts, so that the outer side of this can be provided with waterproofing, and then this gap is filled up. How much expensive it is to have an RCC diaphragm wall and just leave it buried inside. The other problem is too much of struts and making the construction below miserable. The third problem is when the diaphragm wall penetration is not enough, you can have a piping failure. And please note, dewatering should be carried out only outside the diaphragm wall. If you are doing it inside, you must make sure that the gradient is safe and it doesn't create piping. At this particular site, there was large subsidence, about 300 millimeter, making a small control building which operates the belt conveyor to sink by more than 200 millimeter, leading to various cracks and inclinations. People have been using different system. When the depth is shallow, you use Berlin wall or steel pipe as a retaining structure. You can see a bulging taking place here. And when the bulging increased, inclined strut is provided, supported on the RCC pile used, installed for the building. Now these piles are free-headed, they are not connected with pile cap. And when it gets this additional lateral force, we need to see whether it is safe. So here again, the lateral soaring by a pipe pile, which there was a failure, pipes tilting inside. And as this soaring system gave away, the ground in front also got pushed and displaced two of the permanent pile inward by about 500 millimeter, as you see in this picture. So obviously these piles which has cracked would not take some required vertical load. So these piles were discarded and additional piles provided to continue with the construction. Soaring piles, we often come across more failure problem for various reasons. I don't know why. And here also you can see a soaring pile has given away. These piles were supposed to be in line with this. And once this gave away, all the soil moved in with the structure, temporary structure collapsed. There's one more RCC pile used as a soaring for a project on Nangambakam Road. You find that because of this failure, nothing happened till monsoon. In monsoon, probably because of saturation and inadequate drain, this soaring pile gave away, leading to a failure. And an important building adjacent to it was without pile foundation and hardly 2 meters away from this. So there can be such similar situation, but you also have successful application of touching pile or secant pile, which has been used with anchors at different places. So lateral stability is not a problem. Do we have any other options? So I'm just sharing one possible solution which was adopted for a building in Chennai on Mount Road. You find that it's a large building. The peripheral area of this is built by top-down method. You have the basement slab already cast for about 15 to 20 meter length from the diaphragm wall. And these slabs are supported by a temporary steel pipe pile. These are not permanent column of the building. And then when the excavation is completed to full depth, the permanent RCC pile, which was installed along with diaphragm wall, get exposed. So you start constructing the permanent column. There are permanent column within the peripheral basement slab cast also. While casting the basement slab, the steel is left out on either side, top and bottom. So you expose on the pile, cast the pile cap and make the permanent column. Once permanent columns are completed, you can knock off this temporary steel pipe pile by just cutting it and then finish the basements. So this, because we need to check whether there are these two rows of steel pipe pile has given adequate support, it is monitored with an inclinometer and found that deflection as well as stresses in the pipe are within the permissible limit. Anchored diaphragm wall, as you see here, you excavate to first stage, there are a series of anchors installed. But what was found is that installation of anchor took a lot of time and it did not meet the schedule for completing the basement casting. So a decision was taken that till these anchors are completed and stressed, we leave a soil bomb, as you see in this picture, and then go to the final level. So at least in the middle area, the preparation can be done for casting the raft. And when this was attempted, you find that there was a movement in this building at the top. This is a small DG-set room, and you can see 100 millimeter displacement just 3 meters away. This is that building where the wall has moved out. So this could be the consequences whenever you try to overlook something because it was not planned and site has taken a decision. Anyway, I will stop here for now so that other speakers do have enough time. I request the participant, if you have any question, please enter it in the question answer box that you have, and we will pick some of the questions and read it out, and then one of the panelists will try to answer the question. So this is from my side from right now, and now I have pleasure in inviting Sri Jaideep Wagh to make his presentation. Sri Jaideep Wagh, please.
I'll start with my presentation.
Yes, please, you can present it.
Okay. Okay. Yes, is my screen visible?
Yes, thank you.
Sorry, I'm not tech savvy. I have to take help. Okay, I'll get started. Jaideep Wagh. I've been practicing for now 25 years as a geotechnical consultant in Mumbai. I will start. Our topic is learning from failures of shoring and soil retention schemes. And I normally start my presentations with thanks for having me. But today I won't say that because I feel I'm called because I've caused the maximum number of failures, or I've seen a maximum number of failures of shoring schemes over the last 25 years. So I have a lot to say, but I've been given only 10 to 20 minutes. So I'll run through everything that I've experienced.
Jaideep, you have 20 minutes. You have 20 minutes, so you can take it.
Okay, thank you. So screen is not moving. Okay. We've seen a lot of geotechnical failures. Typically, I would list geotechnical failures in at least in our experience in three main categories: building pile failures, one is excavation side slope failures, and one is our current topic, which is the third one, which is the shoring pile failures. So I'll be concentrating only on the basement shoring pile failures today. I'll just touch upon this issue, which is kind of related to our shoring pile area. which is excavation side slopes. Obviously, if there's adequate space for side sloping, everybody prefers just providing side slopes. Shoring schemes are only given when there is no space available for side sloping, right? So this is the number one issue that is considered on all basement excavations. Stable side slopes, normally these kind of failures are related to side slopes not communicated to the site, or recommended excavation slopes not executed on the site, or sometimes we give a side slope considering the basement line from the plot boundary, but then we go on site and we find out that there's contractors need working space outside the basement wall, which we had not accounted for, or sometimes there is foundation offsets which are more than what we considered. So because of this, we've seen a few failures happen on the site. And the last is obviously an incorrect recommended excavation side slope, which I guess is our doing. Okay, we come to the main issue, which is the basement excavation shoring. These are the 4 types of shoring schemes. Firstly, what are predominantly used across the world or across India. That is a steel sheet pile. Second is a Berlin wall or a soldier pile wall, what Professor Gandhi just touched upon. There's a diaphragm wall and there's board pile walls. Across India, depending on local preference or local economy, one of these schemes are selected. Mumbai or Bombay is completely board pile walls because the other 3 systems are very difficult to install in rock. And Mumbai, a lot of places we hit rock. North India, if you go, you see a lot of diaphragm walls and soldier pile walls. Soldier pile walls because timber is cheaper there. Calcutta, you see a lot of steel sheet pile walls. So that's a typical steel sheet pile wall. I guess everybody knows these 4 schemes. I'll just run through them. These are very slender sections. So these lead to failures sometimes because of their slenderness. They need anchors or props or multiple level to actually support them. Otherwise, they give away because of their slender ratio. This is a Berlin wall or a soldier pile wall, which is typically timber planks between ISMB sections. That's a typical close-up view of that. Not used in Mumbai because of rock and because of expensive timber. A typical diaphragm wall, which is a continuous RCC wall. This diaphragm wall actually forms a part of the basement wall. So you don't need another basement wall inside the shoring scheme. So it leads to some cost economy. But again, not done much in Mumbai because it's difficult to execute in rock. A typical board pile wall system, a typical Mumbai site, extensively used in Mumbai. And nowadays, there's so many basements across the city that this is a common view on almost every street of Mumbai. Now, the problem at hand is the failure of the shoring schemes. The excavation shoring schemes, firstly, this is the biggest problem. It is considered as an unnecessary cost since they are only temporary enabling schemes. It's actually not contributing to the construction as such. Although, as Professor Gandhi said, sometimes you may use it to retain your permanent earth loads and reduce the steel in your basement wall. But most of the times they are not, because you may have a footing offset, you may have working space, your basement wall may be quite a ways inside. So it's not typically used. And these are very stopgap arrangements which are used in Mumbai, which lead to a lot of failures. These are not failure of shoring schemes, but these are just very rough enabling schemes which are done to save on cost of shoring schemes. So this is the problem. Those are very rough schemes. But even when it comes to a proper shoring scheme, there is a tendency to cut cost because, like I said, it's a temporary enabling scheme only. So shoring scheme failures. There's lots and lots of failures over the last 25 years. We've seen lots of them. I won't, send very few photographs just for depiction purposes, but there's like numerous. This is a famous case we went through 3 years back. Numerous failures. So I won't, show slides on all of them, and that's not the intention. We think about our work And typically we see an average of 2 shoring pile collapses every year on our site. So that indicates a failure percentage, our failure percentage of about 1%. And there are some encouraging friends we have who say you do so much shoring piles, 1% is nothing. That is okay, that is all understood. 1% will fail, not an issue. And there are some discouraging colleagues, friends who say no, failure rate should be 0.00%. Not even one failure is permitted. So I guess I tend to agree with the second view. I wish it happened that way, but there's a lot of factors that are, not helping. Second point, most shoring pile collapses occur in monsoon seasons. And in monsoon seasons, the failure percentage climbs up drastically. I would say we have at least 5% failures. And this doesn't even count for normal issues like being called late at nights for cracks and for soil erosion and for dewatering settlements and for some minor deflection issues. And we get called a lot in the monsoon season. So I would say the failure rate in monsoon season is even maybe 10%. So that calls for some immediate measures to be taken to avoid and prevent these failures. Common causes of failures, I guess everybody knows, the inadequate, improper geotechnical investigation. The most common thing that comes to mind is normally people do soil investigations for buildings. They concentrate the boreholes within the building area. But an equally important part is the shoring scheme. There's normally very few boreholes or none done for the shoring schemes on the perimeter of the plot. Boreholes are only concentrated in the building. So I would say the time has come to now do soil investigation even on the perimeter. Second is the improper design, which I guess I take a blame for a lot of failures in our past. Over the 25 years, we've learned a lot. I feel we know enough now, but maybe after 5 years, I'll still say the same thing that I didn't know what I was doing 5 years back. Inadequate supervision. I mean, in design, there are a lot of unique cases that over years you tend to learn. I mean, sometimes we come across such unique situations which someone will say you should have thought of that, but there's a lot of different situations underground that keep coming up. And third point is inadequate supervision during construction. I guess an obvious point that needs to be rectified. There's inadequate supervision in a shoring scheme because it's a temporary enabling scheme, so-called waste of construction time and money. A fourth point is material storage adjacent to shoring piles. We've seen a few collapses because of that. Now, reason for design failures. Now, this is, I guess, our area. Human error. That is, I mean, obviously, every time we also are responsible for that. Everybody, probably most people are. Every time something comes back to us, we find that our design, there is some shortcoming, we should have done better. So I guess we need a proper peer review system somewhere. Optimism is something I'm responsible for. I personally, I always feel nothing will go wrong. I've done a lot of design thinking, no, nothing can happen, nothing wrong can happen. But I normally now I've learned that much that I get my design peer reviewed from in-office people who kind of pull me back, who are non-optimistic, and that helps. Third part is inexperience. I guess we've learned a lot. 25 years back, we used to do shore pile, not 25, 20 years back, maybe we started. And there was a sudden boom in Mumbai and of basements, and I guess we were not ready for it. So initial years were, I would say, a lot of our failures we had contribute to inexperience and optimism. Client pressure is something which we should not do, but we normally succumb to that. There's a lot of client pressure on trying to economize and trying to save cost. So I'm personally, biased on that also, which one should not. Inadequate understanding of site conditions. That is another. Sometimes there's such a big hurry to get the work started that there's not enough time to visit the site. Sometimes there may be surcharges, buildings next to it, slums next to it, or old buildings next to it, or level differences, or trees on the site, or lot of other situations. And lastly, there's gray areas in design. Honestly, there's still a lot of gray areas, still a lot of unknowns, and in which I guess we all tend to play with. So that's the reason sometimes you'll find different designs for the same site, and maybe one cannot say which one is correct. Gray areas in geotechnical. It's very difficult to evaluate lateral earth pressures for some conditions, such as sand, silt, clay mixtures. Lateral earth pressures are very easy for sand and for clay. But the moment you have mixtures of soils, it's difficult, becomes very difficult. You need a lot of exhaustive testing facilities to determine, and even that may not be too accurate. You need laboratory testing, proper laboratory testing, which is, I guess, lacking in India a lot. Drained or undrained conditions. There's different parameters for long term and there's different parameters for short term, with no definition of what is long term and what is short term. So it's lacking in the literature itself. There's design groundwater levels. How much rise do you account for in the monsoon? It's a very subjective thing, unless you monitor the site over years. Now, the biggest issue is the hydrostatic pressure for piles with gaps. Normally, shoring piles have gaps in it, a clear at least 100 mm gaps. Does water pressure build up when you have a gap between the shoring piles? There's huge difference of opinions. I know Professor Gandhi just mentioned design for hydrostatic pressure. Do I need to design for hydrostatic pressure when there's a gap in the piles? Some people say, yes, you design for the full hydrostatic pressure. We feel one should not design for, because there's retaining walls are used across the world with small V-poles at every 1 meter center to center. And how do they function, and how does a 100 mm clear gap between piles not allow the water pressure to dissipate? This is a huge debate I'd like to be a part of with eminent people of the field. It's a big unknown, but now what we've done is we've started using partial hydrostatic pressure. I guess we've succumbed to it because we've had failures which we could not explain why it happened in the monsoon. So we've started kind of partially designing for hydrostatic pressure. And that failure in first monsoons, every first monsoon we have a failure. And it's not clear. Sometimes we've done it right and it has still failed. So it comes back to that hydrostatic pressure issue. So there's some research required, or like we've started doing currently is we've started using some form of a hydrostatic pressure. Weathered rock or hard rock. A lot of people think weathered rock is self-standing, nothing happens. But weathered rock always collapses. There's no slope. There's no weathered rock slope in the world which is standing still. Always collapses. But hard rock is something that you'll see sometimes stands vertically, sometimes it doesn't. So what is the lateral pressure you use in hard rock? It's a big unknown. That is look at this slope. It's hard rock, it's hard sound rock. It used to be, and it was vertically standing for several years, and then suddenly a portion of it started collapsing along very smooth sliding surfaces. You can see those smooth sliding surfaces, and they are impossible to determine from a soil investigation. I know there are techniques in which in the core barrel they have a compass attached in which they can map the joints, but that is a very advanced stage of geotechnical investigation. This, like in hard rock like this, someone would tend to use zero earth pressures on the shoring scheme. But I feel this would lead to at least a 2 or 5% chance of the shore pile falling. Now, do we design for this or not? Even I'm not clear what to do. Gray areas in structural design. I mean, a lot of structural engineers are attending this. I'd like to discuss with them sometime. I wish this was an interactive presentation rather than a webinar. A load factor for temporary conditions is almost universally accepted that you use 1.2 load factor, a factor of safety for structural design for temporary condition. But is that correct? I don't see that anywhere in the literature, but it's accepted. But we've temporarily stopped doing that. Earlier we used to, now we use a full load factor of 1.5. Permissible deflection. There's absolutely no guidance given in literature. Very strange. For permissible deflections, I feel India should be the first one to come out with a guideline on permissible deflections. And it's a problem. Like, let's say you even design for permissible deflection of 25 mm. That that can still lead to a crack in the adjacent property. So what do you design for? Even I'm not clear. I mean, I've had sites with cracks, which I thought were because of my permissible deflection, but those cracks led to havoc. They led to evacuation. They've led to filling of the basements without the real reason coming up for the cracks. Cracked moment of inertia. Do we use that for our shoring pile design? Metro people insist that we use a cracked moment of inertia, which immediately leads to a cost increase of 30%. Do we do that or not? A lot of structural engineers design shoring piles. They assume pinned a fixed condition below excavation level for STAD. I'm not sure that is correct, or the point which is assumed may not be correct. Design of capping beam on shoring piles. I never understood this. How does one design the capping beam? For what forces does one design for capping beam? A lot of times now we've done shoring schemes without capping beams. Those have not failed though. So this is a strange case. This is a common. I know a lot of us, or most of us, must have gone through this. Shoring pile design factor of safety often decided considering who lives in the neighboring plot. This is almost strange or funny sometimes, that a lot of owners, even structural consultants, have insisted that I use a large factor of safety because there's a celebrity staying in the next neighboring plot or the building, or there's a municipal commissioner staying on the next building. So you design the wall, you make it doubly safe, you do everything right because there's some, which is very strange. So it shows a lack of proper design principles in shoring schemes. In fact, I myself have spent sleepless nights because one site I designed, I found out later when I visited the site that some superstar stays right next to it. So, but it was too late to change anything, and luckily nothing went wrong. So, but something's not right. Now, we've implemented a lot of aggressive designs. Some have stayed, some have not. This is a scheme we, use short pile, long pile concept, which resulted in a lot of savings. But somewhere I think we underestimated the vertical downward component of the anchors. This was done several years back. We've stopped doing this now. But I feel the system still has merit, done properly. But this requires a lot of site supervision, which is where we went wrong. We should have insisted on site supervision and insisted that the short piles also end on hard rock. This can still be a system of the future, but we've stopped doing that now. We've done piles with large gaps in between. This was done earlier, but we learned very fast that this doesn't work. We've done, this is 20 years back when we thought that a structural steel member can take any amount of infinite load. So we don't do that now. Struts are normally we give at 3 or 5 meter spacing. So no, I wouldn't recommend that. We've terminated piles on weathered rock. We've done rock anchors to stabilize hills, like this scheme here, which it didn't work. Again, I underestimated the downward component of the anchors, which led to a bearing capacity failures in rock. A lot of things we stopped doing. These are again a short pile ending on weathered rock. Normally, if I do it now, today, if I'd extend the piles to that gray rock seen below, but this side luckily worked because there are a lot of buildings next to it, so nothing went wrong here. Few recent cases of shore piles, I'll just run through it. I have quite a few. A typical shoring schemes are done with rock benches, and it's very common. A lot of pressure on us to provide rock benches because the basement wall is slightly inside the shoring scheme. We have some gap. We have 3 meters, so why not give a rock bench and terminate our piles at a shallow depth instead of taking them all the way down below excavation level? This one case, the piles have ended just 1.5 meters or 2 meters below in the weathered rock, but the rock bench collapsed, causing an emergency, and the whole thing had to be immediately backfilled. This is a case where there was miscommunication, there was over excavation done below the pile toe. Once something goes wrong, then there's a lot of that you should have known our excavation level. We had given you drawing. We had, you knew there was putting offsets. You knew there was this, that, whatever. So, avoidable if it's properly planned and if everybody is involved continuously in the project. This was not ours. This was because we've gone through this before with large gaps of shoring piles. We've gone through these failures, but this is not on our side. Large gaps lead to soil erosion. And problem is there are a lot of sites where this scheme has been provided and it has worked successfully. So that is the problem with this. The failure may be only 1 in 10 sites. So we've stopped using these larger gap piles. Some people say we'll provide steel plates and economize, but we've now fixed a principle that nothing more than 100 mm between shoring piles. You see this case where it's just 400 mm and you see so much soil erosion leading to settlements and collapses behind the piles. The piles stayed, but the soils kept collapsing behind. So we've come to a principle where, we don't do more than 100 mm.
Jaideep ji, I'm sorry.
Yes, sir.
You are exceeding time, so please continue.
Yes. I'll run through. Secant pile system to provide interlocking. Failures due to nalas, a very common occurrence. So one needs to see nalas next to the shore piles. This is a common, very clearly the nala causing failure. Again, you can see the stream of water behind. This is a case where there was a lot of hill runoff underground, which now taught us that we need to study surrounding ground topography also. This is another failure by nala. You can see the hydrostatic pressures caused by the nala. Now after seeing this, I guess we are very convinced that we need to design for hydrostatic pressure, whether there's gaps in the shoring piles or not. So we've started designing for hydrostatic pressure. This clearly indicates you need to do that. This is a famous case, I guess, caused 3 years back. Again, I mean, a lot of things, debates on this, but this case taught us more learning from failures. We learned more on, the problems and the issues that a shoring pile failure can cause. This is an anchor block failure. Small things can go wrong in shoring pile design. You see that anchor fasteners, those are slightly extended. The curve plate is not touching the shore pile, which caused, the 2 anchors to slip down and caused cracks in the adjacent road. So there's small things. One needs to supervise all these things. This is another unique case where it was self-standing rock, but the surrounding plot had a previous basement, which was backfilled. So that backfilling soil and the water sitting in that caused a collapse on our site. Whereas we had assumed that the rock is self-standing, but we didn't consider that there's a basement behind and it's backfilled with soil, which can get filled with water and can cause the hard rock column to collapse. These are issues on what small cracks in the adjacent to shoring pile can cause. There were cracks in the pavement which led to a stop work notice and filling of basement. Again, another crack in the adjacent plot where the basement had to be then strutted, given another row of anchors. This is a 25-meter diaphragm wall where we learned that, when you have so many anchors, they all cause a pressure bulb influence, and the pressure bulb together causes deflections in the adjacent plots and buildings, overlapping of anchor pressure bulbs. So this was another thing which I guess after it happens, people say you should have thought about it, but at that time, this is a 28-meter deep excavation which actually started moving when there was small over excavation from 28 to 30 meters. The whole system started moving in. Which shows how, susceptible it is to planning. Few measures: proper design, periodic supervision, registration of geotech engineers, stringent guidelines, and monitoring, what Professor Gandhi said. Some well-executed shoring schemes are also there. So just so I don't leave you with the image that we don't, all our piles fail. So that is some schemes I would say were well executed by us. This is a 36-meter deep excavation, probably the deepest excavation in India. No issues. This is a 27-meter deep excavation with micro piles, multiple level anchors done in quarry land, completely retaining filled up soil. So a lot of people feel micro piles cannot be used for large excavation. So this was completely quarry land, no issues with that. Okay, that's all. I'll end it.
Okay.
Thank you very much. Sorry for exceeding time.
So, thank you, Sri Jaideep. And it was really very interesting presentation with so many case studies. I'm sorry we had a shortage of time. Otherwise, we would have extended it by another half an hour to learn more from you. I now request Engineer Vaishampan to make his presentation, please.
Yes. Yeah, I'm sure I'm visible now.
Yes.
Yeah. Okay. Yes. Thanks, Mr. Jaideep, for making such a very large presentation with a lot of pearls of wisdom in that. It gave us a lot of hints and understandings. So let me start immediately. I'm going to present only two case studies of failure of retaining system. Very simple one. I'm going to make it very short. Yes, the first case actually had a residential building which was actually in the aviation funnel or the airport funnel or which is in the flight path, because of which actually it has actually height limitations. Since there are height limitations, all the facilities as well as the parking actually has to go into basements. So 4 levels of basements were required, and the design depth of excavation was 13.5 meters. We had done 4 boreholes for this site. We drilled 4 boreholes for this site, and our subsurface stratification for this site was like this. Filled up soil was from 0 to 3 meters, average value of 10. Yellow stiff silty clay from 3 meter to 6 meter, average value of 15. It was underlain by highly weathered basalt from 6 to 12 meters, with core recoveries between 15 to 30 to 50, and which is the bottommost layer was this slightly weathered basalt with a high core recoveries, much more than 90, and continuous below that. What we had noticed was that the rock below 12 meters actually had a crushing strength of 40 MPa. Since that it had a crushing strength of 40 MPa, we were forced to go for a small diameter pile, say 300 mm diameter pile. So we designed the system, and length of the pile was 17.3 meters, which means it had a 3.8 meter of socket length below the excavation level. We actually considered one pre-stress anchor at 3 meter depth, and the capacity of the anchor was 450 kilonewtons. Spacing of the anchor was 1.8 meters center to center. So we went ahead and issued this drawing to client. So the piles were installed. You can see the piles were installed actually nice and systematically. And at 3 meters, the first level of anchors were also installed. On installing during the installation of these piles, what we noticed was that rock at the northwest corner was at 8.6 meters instead of 6 meters, which was as per the design subsurface profile. So instead of changing the pile lengths were maintained the same, and second level of tieback anchor was introduced, and system was made once again stable. The anchor was at 7 meter level below ground, and the capacity of anchor was 600 kilonewtons. The spacing was same. It was staggered with respect to the upper level of anchors. So you can see here in this slide that the second level of anchor was also installed at 6 meter depth, and this is a very short stretch and it was done. But this location is very important because failure just happened on the left side of this. Now you can see the timeline here. The chronology of the event was like this, that in the first week of March 22, the installation of piles was completed. In the first week of May, the installation of anchors and weather beam was also completed, and excavation up to 13.5 meters was also completed. So we are ready to start the basement construction. But for some unavoidable reasons, work was held up, and right up to June 30th, no work was done. On June 29th, actually, it was reported that 2 strands, the 2 adjacent anchors actually snapped. So, we somehow could not go to site that day. So on the June 30th, morning of June 30th, the night there was a very intense rain overnight, and basically what happened was, because of the additional water pressure, the retaining piles near the anchors actually toppled. You can see that you can see the second level of anchor here. This is the point where it is failed. There is a cavity underneath, you can indicating flow of water from the ground. And one segment of the piles actually came down. You can note that the remaining piles are standing comfortably and safely. Naturally, what are the reason for the failure that we had to sort of determine? So we actually went about revisiting our design. So we looked at the destabilizing loads. We looked at active earth pressure. There are no change. Then we looked at hydrostatic pressure. There are no rains, so there was no change. The ground water table had not changed, and there was as we just now pointed out, there was a gap between the piles. The third factor was the active pressure due to surcharge load. Now, surcharge load can happen because of stacking of excavated spoils or construction materials. You can see in the slide that is absent actually. Sorry, 1 minute. You can see that there is no material on top. Second thing could be adjoining buildings. The footings of the adjoining buildings also can the load can cause the additional surcharge load, but the building is also quite far away, so even that cannot cause the failure. The third thing was the construction vehicular movement during the construction. But when the excavation was done up to 13.5 meter, dumpers have come and gone. So dumpers were actually standing very close to these piles, and the piles had performed perfectly. So that means there was no problem with the design actually as such. So we also looked at the stabilizing loads, whether there was any review was required from passive pressure of rock and horizontal load reactions. We looked at the equilibrium again, and everything looked correct. So the only thing that could have changed in this case was surcharge load. So we inquired and made a lot of inquiries, and it was pointed to us or told to us or informed to us that to lift the poker up to the pit, a crane of 100-ton capacity was brought to the road on the west side. The crane stood very close to the retaining piles, and it tried to lift the poker out. And but then they did not take the poker out and left it there, and then they went away. And right at that moment, the anchors had snapped. So it was very obvious that surcharge actually increased. So we looked at the parameters of the crane, and we actually came up with the surcharge of 25 kilonewtons per meter square be the most likely surcharge on the safer side. And we looked at the failure, and then we now compare in front of you the design condition and the failure condition. The surcharge was originally 10 kilonewtons per meter square. It was there in design, and there's an increase up to 25 kilonewtons per meter square. The shear force on the pile was 60 newtons. It went on to 78. Not great change. Bending moments actually from 33 kilonewton meter went right up to 212 kilonewton per kilonewton meter. Significant change, 5 times almost. And lateral deflection of pile, which was estimated deflection was 14 mm, and you can see the piles are standing perfectly. So that is probably correct estimation. The thing changed from 14 to 148. Now this was way beyond the breaking deflection of any pre-stressing strand of 76.6 for the given condition. So it was obvious that the anchors were overloaded and the strands, that's why snapped. Now this was once we realized this, so what are the takeaways from this situation? In this particular case, the most common cause of failure, high intensity rain, was not the cause, not the reason at all. The surcharge load, which is normally considered less important factor in design of retaining scheme or system, but in this case, we notice that it is as significant as earth pressure and hydrostatic pressure. The anchored retaining systems are more susceptible to failure by accidental increase in the surcharge load. And in case of small diameter piles, fourth one, the deflection plays very vital role. It should be checked at each and every construction stage to make sure that the deflection is not exceeding. So this is where we actually ended the first case. Let us look at the second case now. Now this was a successful situation. There were a lot of change. There were change in design condition, but then we could redesign the system and we could actually successfully complete the work. Now this was a commercial building with 4 levels of stilt and podium above ground and 18 upper floors above that, and 1 level of basement. 1 level of basement was below road level. The project actually is located on a hill slope partially, and partially on the flat ground. So starting from road, it climbs with the hill slope and goes up. So total level difference in the hilltop and basement is as much as 34 meters. That's why it was significant, and that's why we selected this case. Now there are two buildings on the top, actually top ridge or the near the excavation line. Very, very close. You can see in the photograph after that. They are merely at 1.8 meters from the excavation line. So we had to, once again, we looked at the investigation data. So we had 6 boreholes drilled along this alignment. We inferred this the design profile. Filled up soil was 2 meters. Then completely weathered rock was from 2 meters to 4 meters with proper N values more than 32 also. And then it was followed by highly weathered basalt from 4 meters to 8 meters. The core recoveries here are only between 20 to 40%. This is somewhat more bouldery rather than continuous or discontinuous rock. And it was followed by slightly weathered basalt below 8 meters with a very high core recovery, more than 90%, and also very high RQD, more than 70%. Crushing strength of rock below 8 meters is also more than 50 MPa. This all, obviously, we are then these two factors forced us to go for the 300 mm diameter piles. So we designed the piles with the 2 levels of anchors. So diameter of pile was once again 300 mm. Length of the pile was 3 meters. So below 8 meters, 3 meters socketing into the hard rock. Now the first level of anchor was provided at 2.5 meters. Second level of anchor was provided at 5 meters. Both were passive anchors. The reason was that the strata actually behind that was bouldery, and it would be difficult to drill through that and to sustain the stability of the drilled hole for grouting purposes later. So we actually tried to keep the duration as short as possible. So we insert the rod and grout immediately. So passive anchors were preferred. They were taken quite close to each other. And we actually had planned 2 meter rock ledge at 8 meter depth. And now, just to make sure that the rock ledge actually is continuous and strong, because it was a substantial length, as and where, supposing if we find fractured rock, we had made a provision of rock nails with shotcrete for the fractured rock pockets. Let's go to the next slide. Okay. Now, during the installation of this retaining scheme, almost all the piles were practically installed. 300 mm diameter piles with 2 levels of anchors and 2 meter rock ledge was completed. On installation of piles or a completion of piles, suddenly there was a change in the planning, and client came back to us saying that he has a space requirement and he needs to do away with the 2000 mm rock ledge, and he said that I wanted space for something in building. So he asked us to do redesign of retaining system by completely removing rock ledge to substitute the passive force generated out of the rock ledge. Then we actually proposed, or we designed and installed another level of anchors at 7.5 meter depth with somewhat higher, shall we say, the capacity. You can typically look at this picture here. You can see the building on the top of the hill. There are 2 rather old buildings, and they're very close to the excavation line, and the piles are standing. This is a runner beam, followed by the first level of anchors at 2.5 meter. This is followed by 5 meter level anchors. And this is an intermediate stage, picture taken. You can see on the left side, there are 2 persons working here. And if you see that there's just below there, the piles are actually, they're being exposed. So we asked them to expose this section by section, put the welder beam and put the anchors so that we are safe. And then progressively this further excavation are done on the right side, and we went on to do the entire length about almost around 80 to 100 meter length. So wherever the fractured rock was found, strengthening was done once again by rock nails and shotcrete. So changes in the planning was needed in the retaining system after partial installation of retaining system. These were informed to geotechnical consultant in time. So accordingly, modifications in design could be made and keep the retaining system safe enough for 4 rainy seasons. In this case, the point to be stressed here is there is an excellent communication between client, architects, structural consultant, and geotechnical consultant. This was actually a requirement of all projects. This is a requirement of all projects, And if this is achieved, probably we can do a much better job. I think I complete my presentation with this. Thank you.
So thank you, Dr. Vaishampan. It was very interesting, both the case study you have described in detail, the analysis and the probable reason for the failure. Without losing much time, we go to the next speaker, Dr. H.M. Raje. Kindly stick to the timings, about 10 to 12 minutes, please. Dr. Raje, please. Dr. Raje, you are not audible. Can you unmute? If you're...
Yeah. Hello. Good afternoon to everybody. First of all, let me thank SEFI Forum and special thanks to Alpha Madam who has given the opportunity to present our site experiences of shore pile failures. I would stick to, I have been undergoing a lot of failures right from 2009 onwards. I have taken only 5 cases and limited myself to the photographs and not to the root cause analysis or the detailed part of it. So let us start the first case study. This was a backfill area and there were tanning industries in this particular area. And after the excavation, the failure has taken place. You can see the areas, cracks in the roads were formed, settlement in the road was seen on the pile. And one of the anchor, which was in the worst area, corrosion took place because this excavation, when they excavated for some certain days, they kept this for about 1 year as it is. And therefore, there was a severe corrosion and the whole system failed. So when a system fails, it's a big problem. You can see, let us take the case study number 2, in which there were 2 basements, depth of excavation was 12 meters. And over here also the design was under design and there was an additional surge load. When the excavation was in the progress, the client, without even thinking that there was a level of anchor over here, they thought of directly excavating, and when they excavated, the piles failed. So here the collapse of shore piles due to active pressure acting on the piles and heavy surcharge load from adjoining roads. I'm just going through the case studies. Here 12 meter basement, 12 meter deep of depth excavation, 2 basements. Over here, what happened is that, in this particular zone, there was a long length sewerage tank and this was abandoned. Now this area, total pulverized soil had taken place. When the shoring was completed over here, what happened is that the architect also thought of going for about 1 meter more, and suddenly this slip circle took place and the failure had taken place. So you can see this area completely failed. And apart from that, at certain areas, the weathered slippage of mass also started to keep taking place. This was 3 basements. And in these 3 basements, the anchoring was done from 3 phases. And in one phase, since the adjacent property had not allowed us to do anything, we had done nailing. Now, what happened during the monsoon, the complete their drain was very close by. And the drain they had left open this drain directly to the side. Now, during the heavy monsoon, when the terrace got fully flooded, they left that complete water pressure over here. And one by one, all the nails started collapsing. This is a zone where their drainage was there and the full drainage pressure came over there and all the nails started collapsing and this particular phase collapsed. The system of collapse was slowly and steadily, their own drainage walls started getting cracked. The compound wall got cracked and the whole failure took place. I have all the videos and I have all the root cause analysis done over here, but I am more interested to show how the failure has taken place. Luckily for this particular adjacent building, this building was standing on piles and therefore we saved, otherwise we would have had a major problem. This is the latest case. This is 17-meter deep excavation. Excellent type of design was carried out, but there was one tree which the corporation did not permit us to remove. And most importantly, all the rainwater was, the runoff of the rainwater was directed towards this particular basement. And this was in the sloping area. Now, what happened is that when the heavy rain took place, the rainwater passing through the SWDD was absolutely flooded and full pressure came onto the tree collapsed and it hit those particular piles. We can see actually literally 3 piles broke away from that. There was no major failure, but only this particular zone had failed and the pile collapsed. Now, let us understand these failures occur due to uncalled issues, which are often missed by supervising authority team. From our experience, we humbly advise all our engineering fraternity to take uttermost care and address for any uncalled situations and have proper discussion with clients, supervision authority, architect. Following points must be addressed to the client in construction. Actual reconnection survey of surrounding structures and utilities must be carried out prior to actual execution of the shoring. We have to see what are the adjacent properties, what is the distances, what are their loadings that are being placed by them. Mapping and checking adjoining structures and their current distances from actual shoring site. Carrying out audit of existing structures prior to any shoring sequence or any construction activity at the site. If any drainage lines or stormwater drains are running parallel, where shoring will be carried out. Now, here I specifically want to let you know that when we do these deep excavations, the first thing that we do is that we take audits of all the adjacent buildings and we document it properly, because sometimes what happens, and they have been warned that quite possible their compound wall might come down. So, and we take an undertaking. So what happens? There is no ill feeling between both the parties. More importantly, after the failure takes place, they should not come and say that the cracks have occurred because of your excavation. So therefore, a proper audit of all the existing structures with proper documentation should be carried out. If the site is in sloping contour area, it is essential to warn the geotechnical engineering consultant and the supervising authority regarding the maximum possible water runoff, which may be directed to the shoring site. This is an example of what had happened to our site, where when the complete water flow came over there, it hit that tree and that tree hit that particular piles. Interpreting geotechnical report for any groundwater table variations, cross-checking geotechnical drawings prior to any commencement of work. If any discrepancies must be immediately reported to geotechnical engineer. Here I would say that the geotechnical reports which we have in way back in 70s and 80s, that particular type of geotechnical report should come back into action, because they are all detailed reports with continuous sampling and systematic approaches are carried out. Carrying out site visit during actual execution of shore pile. This is also very important, because the first 2 failures what we had seen is that the diameter of the pile and the spacing of the system when the failure took place was not exactly as the way the design was projected. So this is very important that and the last failure that we have seen over there, the veiler beams and the steel cuttings or the hilty anchors, what they had done, that hilty bolts also they had changed the complete calculation, variations of the site were observed, and this also has caused the failure over there. Checking piling length as per drawings and details submitted by geotechnical engineer. This is very important, because as I told you that in the drawing, sometimes when you give them the soft copy, they either change the diameter or sometimes even they change the reinforcement. This has been experienced, because these are just not 5 failures. There are a number of failures that I have, and in each of the failures, I have clear-cut root cause analysis, geotechnical report, and that is all self-extended, but I am limiting myself to this particular part. Conducting pile integrity tests for checking and discontinuities. Apart from that, I would suggest that the tiltometers, deflectometers, all these things at pressure gauges have to be measured, especially when we are doing deep excavations in near the marine clay areas. Most important is geotechnical report and the selection of proper executing agency, because when the agency is brought on the board, sometimes they give the advice to the client. They say that you are the structural engineer as well as geotechnical engineer does not have proper knowledge, and we have done this type of excavations and nothing has happened over there. So this is very important, that your geotechnical report and selection of proper executing agency has to be there. Apart from that, another thing that I would request is that in the geotechnical design of the shore pilings, it is also predominantly important for us to do some manual calculations. We cannot completely depend upon the software. This is what I'm realizing nowadays, that it is totally given on software and nobody has got the idea of the what exactly might happen. So it is essentially required that some practical calculations are being projected and then re-verified with the theoretical software calculations. I've cut short my this thing because I don't want to overextend, but basically I have undergone many failures, and all the failures root cause analysis with videos are existing with me, but I have limited myself to the tragedy a structural engineer undergoes when the failure takes place, because he loses the sleep and he is the first person who's taken behind the bars. So therefore, we have to be very careful about this type of failures. Thank you very much.
Thank you, Dr. Rajeev. Really, this was very interesting case study. We have the next panelist, last but not the least, Professor D.N. Singh. I request Professor Singh to make a presentation, please.
Professor Singh, you can unmute yourself.
Is this fine now? Can you please hear me?
Yes, thank you.
Yeah.
Well, thank you very much, organizers, for giving me this opportunity of being a part of this very interesting discussion on the learning from failures. And I have the good opportunity of working with some of the panelists. Professor Gandhi is just like my guru in the subject, and I got a good opportunity to work with Mr. Veshampayan, Dr. Rajay, and of course, maybe his team of other members. I was amused to see the geotechnical engineering concepts being made so difficult on a Saturday morning, which gives shiver to me. Truly speaking, it's not such a difficult subject, and most of us are enjoying it, believe me. So what I'm going to do is I'm going to take you away from the shoring systems, and I'm going to showcase to you some of my learnings, which are through the soil retention systems. And this had been a very good experience for me to become a better engineer. I would like to differentiate between the soil retention systems related to the different habitats. And to me, it comes like there are two categories. One is the man-made anthropogenic retention systems, where the soil is being replaced by the industrial waste, in which I research and I am doing a lot of consulting in this area. Mostly in the industrial premises, you have these type of situations which are occurring. And imagine the amounts of materials which are lying in the bulk, millions of tons being produced per day. The second category is the natural soil retention system, which is in primarily non-industrial facilities. You may say municipalities or maybe the civic bodies. So I'm going to talk about now these two situations, very challenging situations that made us introspect, and particularly to me, because both these situations are related to the failures which are still being investigated. And I hope you can understand the triviality associated with the soil and the subject itself. So while industrial establishment contribute to the economic growth of the country through the good output, the big challenge is what to do with the bad output. and which is the industrial byproducts. So some time back, I'm sure you must have come across this news. In the eastern part of the country, there was a breach of the fly ash dam, and then this was a major disaster. And it so happened that there was another instance of breach of the holding ponds, which are known as disposal ponds also. What you are seeing over here is the spill over of the stacked red mud, which is a very highly toxic material because of its high pH value. And what you can see over here is that there is a railway line train which is moving very close to this facility. And this happened to be the Rajdhani route. And what you can see is after the failure, the whole thing got spilled over. And these are the retention systems which have been designed by the agencies. This is a famous failure which took place in October 2010 in Turkey. This is known as Ajka Aluminium Refinery, Hungary. We are very lucky that this type of situation has not occurred so far in our country. And for that, we should thank God. Before the failure took place, everything was so serene. However, this is how the red mud, which is the extract or the residues coming out of the alumina refinery, this is how they are stored. And one fine morning, there was a breach in the dam. And then now you can realize that the entire toxic waste found its way down in the complete village. So these are the photographs post disaster, and hope you can realize the material, which is about 12.5 to 13 pH. If you come across this type of a thing, what's going to happen? I'm being a geotechnical engineer and environmental geotechnologist. A lot of damage gets done over because of this. So what are the issues and challenges which we should be bothered about? The first thing is that you have to estimate the potential impact, which I call as threat, of the industrial byproducts which are stacked and disposed at various industrial units. And when we talk about the threat, this is on the geo-environment, which is the air, soil, rocks, groundwater, and the neighborhood. I hope you can realize these situations are rare, but whenever they occur, they are catastrophic. So what is the reason? It's not very easy to define how these retention systems are failing, but the mind always tries to find out the easiest path, or the least path of resistance. And we say that because most of these disposal facilities are aged and they have already lived their life. They are already exhausted as far as the capacities are concerned for disposal of the next batch of the waste material. So this is a big challenge on which geotechnical engineers particularly are scratching their head, and very challenging task, I'm sure you must be realizing. What's happening is that industrial process cannot be stopped, particularly in the era when we are talking about Make in India and Atmanirbhar Bharat. We have to encourage our industries to go ahead the way they are. Of course, keeping in view all the statutory norms in place and the best possible engineering which can be done. So another obvious reason for these type of situations which might be occurring is because of the non-availability of the land. These areas are quite remote and there is no facility by which these disposal ponds can be expanded. So ultimately what happens is that the tendency is to keep on increasing the height of the disposal facilities. And that's what is becoming extremely detrimental. Not because of the poor design, not because of the poor investigations. What it requires is a very good understanding of the material and how it's going to behave. Unfortunately, the type of situations which are being discussed in this forum are creating a very hapless situation. And particularly in the industrial scenario, the question is whether we should stop the operations, which was done for some time as a knee-jerk reaction from the municipal bodies as well as the environmental watchdog. But then they realized very soon that the entire flora, fauna, and the population harps on these type of facilities. So if you are stopping them, then there's a big question mark on the country's development and so on. All socio-economical, political issues become very, very important. The second issue which Alpa was talking about, fortunately, I was a part of this. I got a very good opportunity to work with Dr. Rajay and my other colleagues from BMC. Well, this happened during the high peak COVID time on August 5th, 2020 at Kemp's Corner, Pedder Road, what she was talking about. This was the situation when we visited the site. Dr. Rajay was also there. I also visited the site at that day. And then we started working on rehabilitation of what is known as NS Patkar Road. And I'm sure those of you who stay in that part of the city or must be passing by, you must have realized now how it looks like almost that you are in a absolutely, well-developed city, and extremely good facilities have been created over there. And BMC has a lot of other facilities and plans to decorate it further. What are the issues and challenges here? It's very difficult to establish and estimate the vulnerability of the hillocks, the cuts and the excavations. I am quite aware of in this area what type of excavations are being going on and how the failures are being taking place, and within the municipal jurisdiction. So again, we can attribute these failures to the aged system, under or improperly designed systems, no maintenance, and many times abused retention system. So I learned from my mistakes, which I did about 20 years back when I gave the designs to MADA for making the retaining walls. And now you can realize that how these retention schemes are being misutilized by the nearby populace. So the retaining wall has become a foundation, part of the foundation system itself, which is very, very unfortunate. There's no maintenance at all. Look at this. The whole building has come over the retention scheme, for which the retention scheme was never designed. So I got my lessons from here. And these situations were helping me. In fact, at the back of the mind, always this conversation was going on that how to create something which is going to be more iconic. And it so happened that from my involvement in these projects and similar projects, I could become a part of some very iconic structures which have been created in the city in the recent times. Those of you who have gone to Navi Mumbai International Airport, I was the consultant to CITCO, and this 60-meter wide north side wall has been created in extremely difficult circumstances and terrain. Hope you can realize that some part of the excavated soil mass is completely waterlogged, because on the right-hand side, what you find is the tidal activity most of the time. This side is the Panvel area, and this is the creek. So most of the time, the water remains logged, and it's extremely difficult to lay the foundations over there. This is how another picture, another view of Navi Mumbai International Airport boundary wall, which is about 5.6 kilometers. And it's a dual system, which is a retention scheme as well as the pavement connecting the Amramarg and the Panvel side. This is the new Marine Drive, which has been created by CITCO at Navi Mumbai International Airport. I'm sure some of you must have driven over there. Those of you who have not, please go and have a look at this. Extremely difficult site conditions in the form of about 15 to 20 meters soft clays, marine clays, and on which a retaining wall of height about 11-12 meters has come over now. My another interesting project, which made me learn a lot, is Dharamshala Skyway, and I'm sure you must be aware that what's happening in the Uttarakhand and the northern part of the country these days. You might lose your sleep also. The type of landslides and the building failures are taking place. And grace God, this Dharamshala Skyway is standing over there. And if you look at this is quite at elevated height. It's approximately 30-35 meter high from the road level. And this is what is known as the a lower terminal of the ropeway or the skyway. This is the upper terminal where the ropeway ends near the McLeod gun, and hope you will realize the type of retention system which was provided for creating the foundations was extremely intricate. Somebody was talking about creating the foundations in the boulders. I disagree completely. It's not so difficult because I hope you realize that the geography and geology of these regions is riverine, and you have mostly conglomerates. So conglomerates are a combination of fine grained material as well as the boulders. So this whole system sits on the conglomerates. Only thing is that you have to do an extreme intricate study of the subsurface and then provide the foundations over there. So foundations are mega foundations, and well, they are standing there, and the ropeway is operational. And very recently, it's a classic case of how negligence can create a failure of the retention system. This was done by someone where you can see the type of retention scheme which was created and was supposed to be here because of the active thrust of the soil has got displaced by certain tens of meters. Again, a good example of how ignorance and lack of design, lack of understanding of the subject might cause the failures which we might be attributing to the divine activity, which I don't agree with. Thank you so much for your kind attention, and I'll be very happy to hear out your views on this. Thank you very much.
Thank you, Professor Singh. So I think we have still about 25 minutes, and the participants have put up a few questions. We'll try to run through as much as possible. And I may request some of the panelists also to help me to get the answer which participants have raised. We start first with a question by Mr. Manish Megnandi. He has raised a question about anchor failure. Should be designed as we should be design anchor as a permanent structure. I think I would like to answer that no, it is not a permanent structure. Once you are ready with the basement floors and structure is ready, the anchor becomes redundant. It was required during the construction period when you are doing the bottom-up construction. He has raised another question whether the testing of the anchor should be rigorous. The answer is again no, because every anchor which you install, you are going to pre-stress it and lock it. So in the process, you do test it to its required capacity. So you don't need to have a very rigorous testing of the anchor. You may need few initial anchor tests to establish the capacity. The next question we have is from Sandeep Kulkarni. And he has raised that how many number of boreholes should be required for shoring design. There was a point made by Mr. Jaideep that it is missing along the periphery. So, Mr. Jaideep, would you like to answer this? Are you there?
Yes, I would say every 30 to 50 meters,
Yes.
depending on depth of basement and other issues.
Okay. Yeah, that's right. I think even IS 1892 mentions that every 50 meter, if you have a detail, so 30 meter will be still better for this important depth deep excavation. So there is next question from Mr. Akhil. Is Akhil Kumar. He has said which software is better for shoring design. So Mr. Jaideep ji, आप फिर से can you suggest what software is more suitable for shoring design?
There are numerous softwares available. Depending on a lot of softwares have different capabilities. Like if you want to analyze rock bench, Wallop, I guess is one of the most utilized software. It's a finite element software. But now with the latest advancements, there's a very advanced finite element software available like Plaxis. I feel they have some issues. Finite element softwares depend on the deformation characteristics of the soil. So it's a whole new area. There's earth pressure softwares which rely on triangular earth pressure distributions. So there are two different, but latest is these Plaxis and Wallop, I would say, finite element softwares.
So they have a choice depending on the application which is required. Now,
may I ask a question related to that, Professor Gandhi, to Jaideep maybe?
Yeah, go ahead.
So I am just speaking on behalf of the structural engineering community. You know, recently, this is an experience I had just last week. And I was, one of my projects was being peer reviewed by a very young, smart structural engineer. And he was trying to tell me that, you know, the kind of parameters that we had used for the raft were highly conservative. And of course, it was given by a geotech consultant. And he said that, you know, he had the Plaxis software and he has done it himself. And, you know, and it was very interesting that he felt that, you know, maybe geotech consultants are very conservative and we as structural engineers need to intervene and not take what they say at face value. And I had a really hard time because, you know, what happens is that if it goes to a client, the client generally feels, you know, you'll use a lot of factors of safety beyond what is required. So, Jaideep, what is your opinion about structural engineers jumping in and trying to do the job of a geotech consultant just because they think that they have the software? Do you think we have a competency to understand soil? Because I think from what I heard, even geotech consultants are struggling, you know, to understand soil. What do you think about it?
No, I feel I must give credit. Structural engineers in India especially have been doing geotechnical also all their lives. It's just, we are just recent entrants. So we have a lot to learn from them also. But at the same time, we've already been practicing 30 years and we still find our knowledge to be inadequate. And structural engineering is so vast that I don't see how someone can get expertise of this small, I mean, seemingly relatively small area of geotechnical. So I feel our input is necessary. As far as we being conservative, that's not true. Earlier days, if you see, bearing capacities were on the order of 40 tons per square meter on hard rock just 15 years back. Now we use 500 and 1,000 tons per square meters bearing capacity. Pile capacities were only, you know, for 600 dia, for 1,000 dia, maybe 300-400 tons. Now we use 1,500 and 1,500 tons on a 1,000-1,200 dia pile. So I don't see where the conservatism is. I don't think that's completely right. Maybe just some isolated project. So no, that's not. Yes.
Okay, I'll continue on the questions. We have next question from Mr. Bangalore Swami. This again refers to Mr. Jaideepji. You mentioned that we need to consider partial hydrostatic pressure on the shoring system. So he's asking what percentage should be considered partial hydrostatic load in the shoring system. Any rough guideline if you can?
In soil, we've started considering full hydrostatic pressures. In rock, maybe depending on the state of the rock. If it's hard rock, we don't consider any hydrostatic pressure in the hard rock. If it's fissured and fractured.
See, my suggestion is.
But I'm open to other people's opinion. I think
my suggestion is.
Yes, sir.
My suggestion is that let's not make these as thumb rules. In geotechnical engineering, you know, most of the things depend upon the site conditions. So I don't think this type of
general answer is possible.
Encouraged. It's not the right way. I mean, taking full hydrostatic pressure, pore water pressures. I'm surprised that why hydrostatic pressure, water pressure is being discussed when the pore water pressures is the right word. This type of things will be misleading, There's nothing known as hydrostatic pressure. You are talking about the soils, you should be talking about the pore water pressures, whether they are of whether they are 100% or some partial pressures you are going to use. So the subject has gone to a stage where everything is deterministic. Professor Gandhi, I think you will agree with me. So see, there's nothing known as thumb rule that I should take 100%, 200%. There should be a reason for why you are doing something.
Yeah, the thumb rule will be based on few projects executed where this percentage has worked well. It has been found satisfactory. But I agree with what you said.
But I think this is where we should be very careful and we should refrain ourselves from generalizing the practice of geotechnical engineering because it depends upon the site conditions and the material.
Okay.
That is the question which Alpa was asking, whether structural engineers should be doing something beyond their domain or not. Well, the answer cannot be yes or no. If you understand the subject very well, if you can really incorporate the material properties extremely precisely, well, go ahead. There's no problem. But then this is a big subject now.
True.
A lot of research is being done, a lot of practice is being done. You have to learn from your own mistakes before generalizing everything.
Right. So let's go ahead. This next question, I think I would like SMP to answer. It is related to the lateral deflection quantity. Normally, it is said that 1% of the height of the excavation should be possible. So is it possible to restrict the deflection to 1% of height? Mr. Alok Bhaumik is asking.
Yes, essentially what will happen is that 0.1% deflection is supposed to be or is relevant to the development of full active earth pressure.
Okay.
And therefore that deflection actually is required. Otherwise, the active earth pressure would not become, it will not get activated, which will mean that much deflection is permitted, but we cannot permit excessive deflection. And excessive deflection is a big question mark. Actually, it has been one of the thoughts, or I've been thinking about it very loudly everywhere. I'm asking a lot of people, but then I haven't found a satisfactory answer to this because though it is an enabling system, nobody is prepared to say that they will allow me deflection more than 1 in 250. Because pile may fail structurally. I asked the question to lots of people, given the most ideal situation, what for a cantilever beam, what is the maximum deflection they will permit without considering the shall we say finishing of the beam, but there is no clear answer. So as far as our design is concerned, for the time being, I would say 0.1% deflection is essential for development of active earth pressure. So it, at the moment is restricted to that. More work is required in this matter.
Okay. The next question from Mr. Vikram Singh Rajput. He would like to know, are there any amendments for structural stability for Pan-India depending on general code of practice? So Jaideepji, are you aware of? Or any other? Dr. Rajay, would you like to answer?
No.
Okay. Fine. So there is no such general code of practice which says that any amendment on the structural stability. Okay, we go to the next our participant Levis Chandra says, how do we calculate the socket length of pile in rock for the shoring? So who would like to answer this? Can anyone?
Is it meant for shoring?
Yeah.
Okay, because that question seems to be very generalized. It could also be in bearing pile also. So it is not mentioned that way. So assuming that because it is related to today's webinar, we'll say this thing. I'll tell you what procedure we follow. Basically, what we do is looking at the average undrained cohesion strength, the crushing strength of the rock in the most likely zone of top 3 to 5 meters in the rock. We actually use the average UCS value. Using that value, we believe that the shearing resistance along that face is required. And so we calculate tau bond. We use the tau bond and we estimate the average or the ultimate shearing resistance along that along the rock face. Or that's why we had defined 2 meter width of the rock ledge, if you remember. So
yes, it's fine. I see a formula given in Dr. N.V. Nayak's book. If you know the moment that is coming on the socket, how you decide the minimum length of the socket so that the stresses within the socket are within the permissible limit for the rock to take it. Maybe that can also be tried along with what you have said. Okay, we go to, there's next question is from Mr. Akif Aksar. This solar pile system is designed in which particular software? I think we have already discussed about this, so we skip it. Lewis Chandra, again, is there any cell life of, what is it, cell life? Self-life?
Self-life.
Self-life for soil protecting, soil piling retention system. Anybody to comment on this? Is there any self-life?
I'll take that, Jaideep Wagh.
Yes, please.
If the shoring piles are designed with the full load factor of 1.5, there should not be any issue to the RCC elements. Only if anchors are used, then anchors have a life of only 2 years as per the British code. We've extended that life depending on the corrosion. We've extended it to 5 years. If you give epoxy protection, it can go on for forever, probably for the life of the structure. If you take a lot of measures for corrosion protection, every steel element to be protected against corrosion. So I would say you can design shoring schemes permanently also. So typically 2 years if it's anchors.
Okay. This next question from Ijaz Khan. I think it's a very generalized question. We did not answer this. It says, what additional geotechnical test is required for project in hilly area? I think one has to decide based on site condition and what is required.
So Professor Gandhi, if I may just add over here, what I think the question is about is, I think Professor D.N. Singh showed that project in Dharamshala.
Right.
So I think what happens, in Dharamshala, there was a project because Ijaz Khan and I are colleagues. So the reason probably he's asking this question is that when we were doing a project over there and we had a geotech consultant who was a seismic geotech consultant because, Kangra earthquake, Dharamshala, so on and so forth. So the client was very particular, and so are we, since we come from the earthquake engineering background, that we need to design for the seismic case. Now, what we were told over there, was that in the event of an earthquake similar to the Kangra earthquake, it is possible for this entire hill slope to actually have a landslide. The slip circle would be so on and so forth. Therefore, so where this question is coming is, therefore, what we were told is that we would have to design piles which would be going down to about 20 meters, okay, in that hill slope. Now, of course, the client was agreeable because he said, if that's what it is, that's what it is. But I think the point which I, as a structural engineer, I'm not a geotech consultant, I'm only a structural engineer. And my concern would be that, geotech engineering, unlike structural engineering, you don't get 2 + 2 = 4, right? There is a certain amount of understanding of soil, and soil is not a homogeneous material like, let's say, concrete or steel, which we work with, right? So soil has two aspects. One is, what is the theoretical aspects. The other aspect is what is the understanding of the soil and how many samples you've taken, right? And the third thing is about perception of risk for different kinds of situations. So, and a lot of it is empirical, right? So in such a situation, we may have been fortunate, unfortunate, I'm not going to get into that, about having had a seismic geotechnical consultant who made us think about putting in these piles, which were 20 meters long. And probably if we had gone to A, B, or C, other consultant, he may have told us, no, it's fine, you're getting this very good weathered rock, and we'll just do a regular landslide analysis for normal situations, and maybe we would not have had to go for that. So how does a structural engineer decide that?
So may I intervene, Professor Gandhi, with your permission?
Yeah, go ahead, please.
Alpa, you have asked very intriguing questions. So first of all, please understand one thing. Geotechnical engineering practice is based on several aspects. Engineering geology is number one out of it, which I am observing that nobody understands, nobody follows clearly. That's the major problem. Number two is you are talking about in a heterogeneous system, which is bouldery, what we call it conglomerate. All right. So Dharmshala and all these regions are conglomerates. You cannot do piling over there. Please remember this. You cannot do piling. It's not easy because, first of all, the material itself is very loose. Number two, how are you going to install the equipment to do the piling? Number three, we don't have piling experts over there. Number four, we don't have the paraphernalia to execute any of these projects by piling. So what you have to do is you have to take care of several factors, Then comes the good geophysical investigations, which I think people have forgotten completely. The geotechnical investigations should be complemented by the geophysical investigations. Please remember something like this. All right, when I was doing Bandravali sealing, each pier foundation we had studied, beyond the influence zone. This is what something known as influence zone. I am surprised that Mr. Wagh was talking about, bulbs, pressure bulbs getting created and distressing the systems. I have never heard of this theory ever in my life. I would like to understand from him, first of all. He was talking about something anchorage and the pressure bulbs getting formed and the distress coming because of that. There's something new for me. Anyway, so coming back to the point, you cannot do piling in these areas. What you have to do is you have to find out the hard strata based on your understanding of the whole geology of the area. Look, most of the landslides are happening because the localized solutions were given. They did not realize that the upper mountain and the lower mountain is a part of one hillock. Are you realizing? So man-made activities are just sitting as a part of this natural system, which is bound to collapse. Please understand this. This is what geotechnical engineering is all about. It's not that just do the piling and find out the bearing capacity and the settlements. Much beyond that.
But Professor Kian Singh, then I'm going to ask you a very, very difficult question. Sure. See what is happening. There are, how does a structural engineer know whom to go to for these specialized projects? Okay, I'm not talking about our regular projects in big cities. I'm talking about these kind of specialized projects, because even within the academia, you go to IIT A and you go to IIT B, you get kind of consultancy reports which are like day and night. So what is a structural engineer supposed to do? We're not experts and we have to look at so many different things.
I'll give you interesting logic. Compare the geotechnical engineering profession with the modern medicine system. If you are not happy, if you're not satisfied, you always go and refer to the second doctor, all right, second hospital. Why? It all based on diagnostics. There's a lot of correlation between what you understand by conducting the best possible investigations and how you are going to use the strata for creating a system of foundation. So your question is, I understand geotechnical engineering practice is not still much matured all over the world and in the country. This requires a very, very concentrated effort on this.
Okay, Professor Singh,
We don't have many.
can I
Yeah, just
request that we are going specific to a project?
just a minute, Professor Gandhi. So the point is, each and every problem in geotechnical engineering is going to be a specialized case which has to be dealt on case-to-case basis. There cannot be any generalized rule. And that's why I'm against generalization of geotechnical engineering solutions. That's what you must be hearing. Thank you.
Okay, I think the number of questions have sort of in last few minutes. So what I suggest is, because the organizer also wants some time, I'll take this last question, which is not a question. It is from Mr. Amit Sheikh, and he's making a suggestion that many of the failures discussed today are due to the hydrostatic pressure and occur mostly in monsoon. So will it not be better that we execute the shoring or piling during the monsoon period, but start excavating after the monsoon is over? It's a good suggestion. We agree to it. Wherever project schedule permits, you should go by that. It will certainly help. So I think there are still large number of questions, but we request the participant to mail it to the admin, and it will be sent to the some of the panelists to get you an answer for it. So over to Mr. Sanjeev or Dr. Alpa to continue.
So, okay, I'll just come in for 2 minutes. I just thought, I think Sanjeev Kumar will do the honors of the vote of thanks. But I think as a participant, and today my role is purely as a participant, I've just been extremely enlightened. And I think it was very, very, not only informative for us, but I think it set a new standard in terms of information sharing and knowledge sharing. And I mention of both Engineer Jaideep Wagh and Engineer Vaishnapan and also Dr. Raje, that they have shared so candidly, so honestly about what they have learned from failures. And I think, and I hope that it sets the bar for other engineers, especially structural engineers, to share about failures, because there is no point in sweeping failures under the carpet. And I would like to just point out, that if we talk about Arup Consultants, and if you remember the Millennium Bridge that was done in 2000, and when it opened, it began swinging when people walked on it, and it had to be shut down. And what Arup did after that was, at their own cost, they retrofitted it, and they talked about it, about what went wrong, what had they missed out, and how did they do it. And I think that by talking about the failure, actually they raise the level of goodwill and the stature in the industry. And I think that's what's going to happen today with all of you who have shared, what you've experienced, because I think it requires a lot of courage to have shared with us. And through your stories, we as structural engineers and other geotech consultants who are also part of this participating today, I think we've learned a lot. So Sanjeev, I'm going to let you do the rest. Thank you so much, everybody. Yeah, Sanjeev.
Thank you.
Thank you, Professor Gandhi, for steering through a wonderful webinar. I will take a minute to introduce SEFI website for all of you. Some 20 years back, we started SEFI with a mission of sharing knowledge among our fraternity. And with that, learnings were aimed to achieving a safer habitat for people. The website currently has 26,000 members, and we want all the participants of the webinar, please join it. You can see here, 26,000 members are there. Please join it. As we launch this series on learning from failures, we also have created a YouTube channel for us that will maintain an archive of all these webinars. So you can subscribe to it. A link was posted in the chat box a few minutes back. Now, on behalf of SEFI, I would like to express my gratitude and thanks to all our panelists, Professor Shailesh Gandhi for steering a wonderful webinar, Professor Dr. DN Singh for sharing their valuable inputs, Professor Jaideep Wagh for sharing first-hand experiences of numerous cases of failures dealt by you, Engineer Shekhar Vesampayan for sharing your case studies, and not the least, Dr. H.M. Rajesh for sharing numerous case studies for learning from failures. Thank you, Alpa ma'am, for summing it up. Can we, with the permission of moderator, conclude the webinar now?
Yes, please.
Okay, sir. Please continue.
Thank you.
Okay. Thank you.
Thank you very much.
Thank you.
All the best.
Thank you, sir.
Thank you, everyone.
So you can